All right, good morning to First Hour Algebra 2. Hopefully everybody had a good weekend. One note on this upcoming week, you only have Monday, Tuesday, and Wednesday. So there'll be no new lessons on Thursday and Friday, or Monday of next week for that matter. This Thursday, I will be around in front of the computer. If you have any questions, you can shoot them to me in an email or on Google Hangouts, and I can address any question that you have on about anything on Thursday, okay? As for today we're going to explore we're going to combine two things that we have been doing. We've been doing SOHCAHTOA and we've done Pythagorean theorem, and we're going to have to put those two together today in our problem. So what we're going to look at here is if we know one trig function, one of our sine, cosine, or tangents, if we know one of them, can we find out a different one? So if we know, in problem number one here, so if we know the tangent is 5/12, can we figure out what the sine is? Okay, well, if we know the tangent's 5/12, then we can lay out this triangle right here, and I just picked that theta to be in the lower left. And if we know the tangent, then we know the opposite is 5 and the adjacent is 12. Now the problem is going to be when we go find the sine is opposite over hypotenuse. Well, we don't know this hypotenuse right here, or do we? Okay, let's now go to this triangle. If we know two sides are 5 and 12, can we find that third side, and how would we do that? Well, we would have to use Pythagorean theorem. What would Pythagorean theorem say about this triangle? 5 squared plus 12 squared equals x squared. Remember one thing about Pythagorean theorem. All you got to do is remember to take whatever your hypotenuse is and put it over there on the right hand side by itself, and you're okay. Now just solve this equation. We get 25 plus 144, that's 169 equals x squared. Square root both of those and we get 13 for x. So now here's our complete triangle. We know all three of our sides. We know the angle we're looking at. Now we can find whatever we want to find. Well, we want to define sine of theta. Well, what is sine of theta equal to? The opposite side, which is 5, over top of the hypotenuse, which we now know is 13. And there we go. We went from only knowing the tangent of theta to now being able to figure out the sine of theta. Okay. On this next problem, you can pause and you can do it on your own, and when you come back, I'll have the solution written out for you. So hit pause now. Okay, here we go. What did we know? We knew the cosine was equal to 7/25, and cosine is adjacent over hypotenuse. So if this is where theta is, then the adjacent side has to be our 7 and the hypotenuse has to be 25. So that's what we know from the cosine of theta being 7/25. Now when we go find our tangent, we got to know the tangent is opposite over adjacent. And here's my adjacent side here. Excuse me, that's the opposite side. Scratch that. We change that arrow. This is the opposite side we don't know. So now how are we going to find that opposite side? Well, we're going to say we know two sides of our right triangle, so we're going to set up Pythagorean theorem. That would be 7 squared plus x squared equals 25 squared. Here you go. Subtract the 49. Do my square root. I get this missing side to be 24. And that makes sense. Remember, your hypotenuse has to be the biggest of the three, and it still is. So now I've got this triangle. I've got a 7, a 24, and a 25. I can find whatever you want me to find. Well, we wanted to do the cosine of theta, which is adjacent over hypotenuse, a over h right there, if you can see that. So my adjacent is 7, and the hypotenuse is 25, so my cosine is 7/25. Okay, so I'm going to have you do one of these. It's going to be a short homework, only 2 problems. So you can have one of these and a Pythagorean theorem problem. That will be all. All right, see you tomorrow.